This is SpaceTime, Series 20, Episode 63. Coming up on SpaceTime, new studies show Proxima B, the nearest known exoplanet to our solar system, is probably a dead world. Calm seas on Titan could mean a smooth landing for future space probes. And a huge storm discovered on Neptune. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims Proxima B, the nearest known exoplanet to our solar system, is probably a dead world, despite being in the habitable zone of its host star, Proxima Centauri. A report in the astrophysical journal Letters has concluded that the Earth-sized world would most likely be unable to hold onto its atmosphere, thereby leaving its surface exposed to harmful stellar radiation and reducing its potential for habitability. The habitable zone is the distance from a star where liquid water, essential for life as we know it, would pool on the surface of an orbiting planet or other body. But just because Proxima B's orbits within Proxima Centauri's habitable zone doesn't necessarily mean the planet's habitable. You see, scientists need to take other things into account, such as whether water actually exists on the planet or whether the planet's atmosphere would survive in that orbit. Having the right atmosphere allows for climate regulation, the maintenance of a water-friendly surface pressure, shielding from hazardous space weather, and the housing of life's chemical building blocks. Our own solar system's a good example. You see, apart from the Earth, Venus, Mars, and the Earth's moon are all in the Sun's habitable zone. But Venus's atmosphere is a runaway greenhouse effect, far too thick, hot, and poisonous. Mars has lost most of its atmosphere, leaving the red planet a freeze-dried desert. And the Earth's moon has no atmosphere at all. Located just 4.2 light-years away, Proxima B orbits a spectral type M red dwarf star. Although only a fraction the mass of the Sun, red dwarfs are intensely violent, with regular bursts of powerful stellar flares. Proxima B's orbit means astronomers can't directly study its atmosphere, and must instead rely on models to understand whether the exoplanet's habitable. So scientists with NASA's Goddard Space Flight Center in Greenbelt, Maryland, used computer simulations to determine what would happen if, say, the Earth orbited Proxima Centauri at the same orbital distance as Proxima B. They used Earth's atmosphere, magnetic field and gravity as proxies for Proxima B. They also calculated just how much radiation Proxima Centauri produces on average based on observations from NASA's Chandra X-ray Observatory. With these data, their model simulates how the host star's intense radiation and frequent flaring would affect the exoplanet's atmosphere. The question is how much of the atmosphere is lost and how quickly that process occurs. That tells scientists how long it takes for the atmosphere to be completely blown away, and compare that with the planet's lifetime. An active red dwarf star like Proxima Centauri strips away the atmosphere when high-energy extreme ultraviolet radiation ionizes atmospheric gases, knocking off electrons and producing clouds of electrically charged particles. Through this process, the newly formed electrons gain enough energy to be able to readily escape the planet's gravity and float off out into space. Opposite charges attract, so as more negatively charged electrons leave the atmosphere, they create a powerful charge separation, which pulls positively charged ions along with them out into space. In Proxima Centauri's habitable zone, Proxima B encounters bouts of extreme ultraviolet radiation, hundreds of times greater than what the Earth gets from the Sun. That radiation generates enough energy to strip away not just the lightest molecules like hydrogen, but also over time heavier elements such as oxygen and nitrogen. The Goddard model shows Proxima Centauri's powerful radiation would drain an Earth-like atmosphere off Proxima B as much as 10,000 times faster than what happens here on Earth. The study's lead author, Catherine Garcia-Sage, says her computer simulation was a simple calculation based on the average activity of the host star, Proxima Centauri. It didn't consider variations like extreme heating in the star's atmosphere or violent stellar disturbances to the exoplanet's magnetic field. The sorts of things astronomers would expect to provide even more ionizing radiation and atmospheric escape. To understand how the process can vary, the authors then looked at two other factors that can exacerbate atmospheric loss. First, they considered the temperature of the neutral atmosphere called the thermosphere. They found that atmospheric escape increases as the thermosphere heats with more stellar radiation. The scientists also considered the size of the region over which most of the atmospheric escape will happen, the polar cap. That's because planets have their most sensitive magnetic effects near their magnetic poles. That's why the northern and southern lights, the aurora borealis and aurora australis, are located there. When the magnetic field lines at the poles are closed, the polar cap's limited, and so charged particles remain trapped near the planet. On the other hand, greater escape occurs when the magnetic field lines are open, providing a one-way route into space. The authors found that with the highest thermosphere temperatures and a completely open magnetic field, Proxima B could be losing an amount equal to the entirety of Earth's atmosphere in just 100 million years, just a tiny fraction of Proxima B's estimated age of some 4 billion years. And even when scientists assume the lowest possible thermosphere temperatures and a closed magnetic field, that same amount of atmosphere would still be gone in just over 2 billion years. The bottom line is that Proxima B's atmospheric loss rates are so high, habitability is virtually implausible. The findings support earlier concerns, including those expressed here on SpaceTime, about the habitability of planets around red dwarfs. Red dwarfs like Proxima Centauri, or for that matter the TRAPPIST-1 star, are often the target for exoplanet hunters because they're the coolest, smallest and most common stars in the galaxy. But because they're cooler and dimmer, planets need to maintain tight orbits around them for liquid water to be present. And while that may be a habitable zone for water, it's a danger zone for atmosphere. Unless the atmospheric loss is counteracted by some other processes, such as an unusually powerful magnetic field, a massive amount of volcanic activity or comet bombardment, this close proximity isn't promising for an atmosphere's survival or sustainability. You're listening to Space Time. I'm Stuart Gary. Astronomers have discovered what could be an easy way to determine the size of a spiral galaxy's supermassive black hole. A report in the Journal of the Monthly Notices of the Royal Astronomical Society claims there's a direct relationship between the geometry of some types of spiral galaxies and the hidden supermassive black hole at their centre. Black holes are so named because the gravitational pull on anything that falls beyond their event horizon, their point of no return so to speak, is so great that the escape velocity from a black hole becomes greater than 300,000 kilometres per second, the speed of light in a vacuum. And since nothing can travel faster than the speed of light, nothing, not even light, can escape a black hole. And because black holes are invisible, astronomers can only detect them by their effect on the space around them. Most, if not all, galaxies are thought to have supermassive black holes millions to billions of times the mass of our Sun at their centres. Astronomers traditionally study them by measuring the speed of stars and gas orbiting around them, which in turn provides a measurement of how massive they should be. Now astronomers from Swinburne University in Melbourne and the University of Minnesota in Duluth have developed a new way for armchair astronomers and even elementary or primary school kids to merely look at a spiral galaxy and estimate the mass of its hidden central black hole. Nearly a century ago, Sir James Jeans and Edwin Hubble noted how spiral galaxies with large central bulges possess tightly wound spiral arms, while spiral galaxies with small bulges display wide open spiral arms. Ever since then, hundreds of thousands, if not millions of spiral galaxies have been classified into one of four basic types, SA, SB, SC and ST, depending on the geometry of their spiral arms. Professor Mark Ziegler from the University of Minnesota discovered a relationship between the central black hole mass and the tightness of a galaxy's spiral arms nearly a decade ago. Now Dr. Benjamin Davies and Professor Alistair Graham from Swinburne University have expanded on this work. After carefully analysing a larger sample of galaxies imaged by an array of telescopes, the authors observed an unexpectedly strong relationship which predicts lower mass black holes in galaxies with open spiral arms of the types classified as SC and ST. In fact, they found the strength of this correlation to be as good, if not better, than any other predictive method used to determine black hole mass. Now, given that it's the disks of galaxies that host the spiral arms, the study highlights a poorly known connection between galaxy disks and black holes. The new procedure also allows for the prediction of black hole masses in pure disk galaxies, those without any central stellar bulge. The authors suggest that this implies that the black holes and the disks of their host galaxies must co-evolve. The discovery will also help astronomers in the ongoing hunt for the long-suspected but as yet still missing population of intermediate-sized black holes, those with a few hundred to several thousand times the Sun's mass, and which are therefore too big to be stellar mass black holes and too small to be supermassive ones. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
How do you weigh a black hole? This has got me rather intrigued.
It's a great story. Astronomers, whilst we see black holes which have similar mass to the sun, maybe 10 or 20 times the mass of the sun, and we see black holes that have got millions or billions of times the mass of the sun, and they're in the middle of galaxies, we don't see anything in between. The so-called intermediate mass black holes, which have masses of 100 to 100,000 times the mass of the sun, are not found. We don't know of any. The speculation was that you will only see them in the early universe. In other words, when the universe was much younger than it is now, maybe half the age it is now. It's 13.82 billion years, by the way, just to give you an age. We celebrate its birthday on Monday. Or actually any day, because we don't know the day. I've got a personal theory, Andrew, which I might have rehearsed before with you on these conversations, that one day we will know the date of the Big Bang, and I bet you £1 it turns out to be April the 1st, and that will really
or February the 29th.
Yeah, that's right. Set the cat among the pigeons. Anyway, back to reality. The news that we are talking about today it's a paper that's published in one of the most august journals of astronomy, the monthly notices of the Royal Astronomical Society, and it's about a really interesting relationship that has been uncovered between the way a galaxy looks and the mass of its central black hole. And this, it's unexpected. That's the correct answer, right? Because why should there be a link between the way a galaxy looks and the mass of its central black hole? And just to cut to the chase, the answer to that question is, the suggestion is that black holes and galaxies basically evolve alongside one another. We've had this debate as to which comes first, the black hole at the center of a galaxy or the galaxy itself. And this seems to be pointing towards the idea that the two basically grow in sync. They actually grow together.
Okay.
Galaxies, of course, are these huge aggregations of stars and gas and dust and something called dark matter. We live in one called the Milky Way galaxy. Its mass is about 400 billion times the mass of the sun, which gives you an idea that there's a lot of stars in it. So it's quite a big one. And we also have a moderate-sized supermassive black hole at the center of our galaxy. There are ones that are much bigger. Some are billions of times bigger than the sun. But this new research gives us a way of actually checking that. So what astronomers have done is taken the sample of known supermassive black holes at the centers of galaxies. And it's not a big sample because, as you can imagine, galaxies being very distant objects, or at least much more distant than the local stars that we can see in the sky, in order to weigh a black hole, you've got to do some very careful observations. In fact, what you do is you look at the motion of objects around the black hole, or the swirling disk of gas and dust around it, and that reveals how much it weighs. But that's a very difficult observation to make, and you can really only do it for the most nearby galaxies, which means galaxies that we're seeing more or less as they are today.
So galaxies that aren't far, far away.
Exactly. Not galaxies.
You do realise that every week
away.
I'm trying to get a Star Wars reference in there. I'm like Jerry Seinfeld always had a Superman in every episode of his show. I'm trying for a Star Wars reference in every episode of ours.
Yeah, okay. Well, look, that's all right. If we get some, if we get some support from the franchise, that'll be very good indeed.
That'll be all right.
So, in a galaxy not far, far away, in other words, one that's nearby, we can actually measure the mass of a black hole fairly accurately. But the new research shows how we might extend that to much more distant galaxies that really are far, far away. Maybe, 6 or 7 or 8 billion light years away. How can we do it? Well, the relationship that has been discovered, it's actually something that's been known for quite a while, but has been really refined in this work. It turns out that when you look at a spiral galaxy, and that's one of these sort of pinwheel-shaped galaxies with beautiful trailing spiral arms that swirl around, when you look at one of those, you can actually measure what's called the pitch angle of the arm. And in other words, it measures how tightly wound the spiral arm is. galaxies. Okay. You can picture this fairly easily. Some galaxies have got very loosely wound spiral arms, and I'm doing the motions with my hand, which I'm sure you can see.
Yes,
and I hope our listeners can as well in their imaginations. Some galaxies have spiral arms that are loosely wound. Some are wound up like clock springs, really, really tightly wound. And it's the pitch angle that determines the difference between those two. But it turns out that if you measure the pitch angle, it gives you a measure of the mass of the black hole. Work that one out.
Like the hub of a wheel versus the
size of the
tire, or the
size of the hubcaps or something. Yeah, that's right. And this comes from measurements of actually 37 black holes that have been measured in galaxies that aren't far, far away, the nearby ones. And they get this relationship that says that the looser bound a galaxy is, then the bigger the black hole is at the center. And they've actually basically give a formula that relates the mass of the black hole to the pitch angle. And the bottom line in this, and I guess the punchline in the story, is that if you want to find intermediate mass black holes, the ones that have been mysteriously missing to date, you've got to look for galaxies with a pitch angle of about 26.7 degrees.
And let me guess, we haven't found any yet.
Well, that's where the story stops. So what's happened now is, because this paper's just been published, you can bet your life astronomers everywhere are saying, right, let's get into the data, looking for these galaxies with pitch angles of that in their spiral arms. So there will be follow-up work on this very, very soon. Maybe our listeners could do a bit of citizen science here, because there are plenty of places on the web where you can download hundreds of thousands of images of galaxies. The Galaxy Zoo is one such place to look at. And yeah, you might just be one of the lucky ones who finds a galaxy with a pitch angle of 26.7 degrees that then goes on to turn out to have an intermediate black hole.
Of course, we could also be looking for something that doesn't exist.
You could, exactly so, because the intermediate black holes have been conspicuous by their absence. But if you want to go and have a look for one, well, plenty of places to go and look.
That's Dr. Fred Watson from the Australian Astronomical Observatory, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Well, if you want to go surfing, the Saturnian moon Titan may not be the place to go. You see, astronomers have determined that the lakes and seas on Titan have few waves higher than a centimetre. The findings, reported in the journal Earth and Planetary Science Letters, means the giant moon probably has little wind, the primary driving force for waves on the oceans of Earth. Titan's the only place in the solar system other than Earth to have rain forming rivers, which then flow into lakes and seas. However, rather than water, on Titan the liquid is methane and ethane. Titan's so cold, the water there is frozen hard, forming much of the moon's surface bedrock. The study's lead author, Cyril Greimer from the University of Texas at Austin, says the findings indicate a serene environment, a good place for future probes to set down on the surface of the moon. So far, only Cassini's European Space Agency lander Huygens has visited the surface of Titan. Titan is the largest moon of Saturn, and one of the locations in the solar system that's thought to possess the right sort of chemical ingredients for life. In images taken by NASA's Cassini orbiter, Titan appears as a smooth brown orb because of its thick atmosphere, clouded with gaseous nitrogen and hydrocarbons. However, the images from Huygens as it landed and radar images from Cassini in orbit show that Titan has a surface crust made of water ice and drenched in liquid hydrocarbons, possibly spewed into the air by icy volcanoes called cryovolcanoes. Greiner says Titan's atmosphere is very complex, and it does synthesize complex organic molecules, the very building blocks of life. He thinks the moon may act as a laboratory of sorts. We can see how basic molecules can be transformed into more complex molecules that could eventually lead to life. On top of all that, Titan's also thought to have an ocean of liquid water deep beneath its icy crust. The research is based on the technique developed by Greimer for measuring surface roughness in minute detail from radar data. Called radar statistical reconnaissance, the technique's been used to measure the snow density and surface roughness in both Antarctica and the Arctic. It's also being used to help select the landing site for NASA's next Mars lander, InSight, which is slated to launch next year. Carry out his research, Greimer examined the three largest lakes in Titan's northern hemisphere: Kraken Mare, Ligeia Mare and Punga Mare. Kraken Mare, the largest of the three, is estimated to be larger than the Caspian Sea. By analysing the radar data collected by Cassini during Titan's early summer season, Greimer and colleagues found that waves across these lakes were tiny, reaching heights of just a centimetre, and they're only about 20 centimetres in length. Definitely nothing to match Torquay, Margaret River or Narrabeen. I'm Stuart Gary. This is SpaceTime. Astronomers have detected a massive storm as big as the Earth on the distant planet Neptune. Neptunian storms can be identified by their bright white vortex cloud features. This huge 9,000 kilometre wide storm system was found in Neptune's equatorial zone, a region where no bright clouds have ever been seen before. In fact, historically, the Neptunian equatorial region is extremely quiet. On this most distant of the solar system's known planets, astronomers usually only see bright clouds in the mid-latitude bands or at latitudes closer to the poles, around 15 to 60 degrees north or south. But this equatorial cloud discovery was truly massive, covering about a full third of Neptune's radius and spanning a full 30 degrees in both latitude and longitude. The storm was discovered by Ned Malta from the University of California, Berkeley, using one of the giant 10-metre twin Keck telescopes on Mauna Kea in Hawaii. Malta says he was surprised to see such an enormous bright cloud at such a low latitude, sitting right there on the equator. He observed the spectacular storm between June the 26th and July the 2nd as it continued to rapidly brighten. Malta and colleagues first thought it may have been the same northern cloud complex seen by the Hubble Space Telescope back in 1994 after the iconic Great Dark Spot, imaged by the Voyager 2 spacecraft in 1989, had disappeared. However, measurements of its location didn't match, indicating that this cloud complex was very different from the one which Hubble first saw more than 2 decades ago. Astronomers suggest a huge high-pressure dark vortex system anchored deep in Neptune's atmosphere may be generating the colossal cloud cover. As the gases rise up in the vortex, they cool down. And when the temperature drops below the condensation temperature of the condensable gas, that gas then condenses out to form the clouds, just like water does here on Earth. However, out in the distant world of the ice giants Uranus and Neptune, it's methane clouds which form, rather than water vapour. As with every planet, the winds in Neptune's atmosphere vary drastically with latitude. So if there's a big bright cloud system that spans many latitudes, something must be holding it together, such as a dark vortex. Otherwise, the clouds would simply shear apart. And this big vortex must be sitting in a region where the air is generally subsiding rather than rising. But just as cyclones and hurricanes don't usually form directly over Earth's equator, a long-lasting vortex right on Neptune's equator would be hard to explain physically. Of course, this isn't the only mystery about Neptune. It's some 30 times further away from the Sun than the Earth, and so it gets very little solar energy to drive weather events in the way the Sun drives weather events on Earth. And yet despite this, Neptune is the windiest planet in the solar system, with the fastest observed wind speeds at the equator reaching a violent 1,600 kilometres per hour. Now, to put this in perspective, the very largest storms on Earth, Category 5 cyclones and hurricanes, have wind speeds of only around 260 kilometres per hour. No one's sure exactly what's driving the winds on Neptune. And if it's not tied to a vortex, the system may be a huge convective cloud, similar to those seen occasionally on other planets, like that huge storm seen on Saturn back in 2010. The problem is, as Saturn showed us, such a cloud should be expected to smear out fairly considerably over a week's time, and that simply hasn't happened. The new observations are therefore showing extremely drastic changes in the dynamics of Neptune's atmosphere, changes which may indicate a seasonal weather event which occurs every few decades or so. Neptune orbits the Sun every 160 Earth years, and so one season on Neptune lasts about 40 years. Having a better understanding of Neptune's atmosphere will give astronomers a clearer picture of this icy giant's global circulation. And that's something that's become increasingly more important in the exoplanet realm, as the majority of exoplanets found so far are bodies similar in size to Neptune and Uranus. While scientists can calculate the size and mass of many exoplanets, not much is known about exoplanet atmospheres. And so what we learn about Neptune could help us elsewhere. You're listening to Space Time. I'm Stuart Gary. A new issue of Australian Sky and Telescope magazine has hit the newsstands, and joining us now with the details is the magazine's editor, Jonathan Nally.
Stuart, our cover story this month deals with what's been called the most mysterious star in our galaxy.
Oh, that sounds interesting. What's that?
That's pretty good, isn't it? The most mysterious star in our galaxy. It's called Tabby's star. That's right, Tabby, like a cat, and it's named after one of the scientists. That's just a shortening of her name. One of the scientists who's been studying it. Now, why is it so strange? Because the amount of starlight coming from it has been flickering or changing in a very strange way. Now, lots of stars do change the output of their light in predictable ways and sometimes unpredictable ways. They flicker and change, and they get brighter and dimmer, and lots of different kinds are known, and they're well known and well understood.
Tabby star doesn't fit any of those categories, does it?
Tabby star does not fit, no. In fact, it's proving very hard to...
in ways which we simply can't explain.
It's proving very, very difficult to explain it so far using known natural causes. So some people have even suggested that the flickering starlight is caused by a giant megastructure surrounding the star built by aliens. A Dyson sphere, yeah, which is like a big... enclosing the whole star basically in a big metal sphere.
When alien civilizations get sophisticated enough and advanced enough, they can pretty well harvest all the solar energy or stellar energy coming from their home star by surrounding the entire star in solar panels. That's basically what a Dyson sphere is.
Yes, it makes you wonder why they would need so much energy, what you're actually going to do with it.
Well, it takes a lot of energy to warp the universe if you want to travel really fast across different parts of space and time.
Of course, why didn't I think of that? Anyway...
You don't watch enough Star Trek.
Don't get me on a Star Trek, no.
Some of the most common other theories for it: planetary collisions causing dust, cometary debris.
The next thing I was about to say about Tabby Star was that's probably a bit far-fetched, but we can say that about Star Trek too, but let's not get into that because I'll get hate mail. But one thing is for certain, no one has yet solved the mystery of Tabby Star, so it's going to be watch this space, no pun intended. Now, Stuart, lots of people like astronomy, and lots of people also like travelling, but can you combine the two? Well, yes, you can.
I can answer that question now, yes. The first galaxies I saw were the large and small Magellanic Clouds, and I was travelling between Sydney and Perth on the Indian Pacific when I saw them. That's a train for our overseas listeners.
Well, there you go, because Indian Pacific is covering, thousands of miles of desert there, and so you just looked out through the window of the train, even through the window of a train with dark skies, you can see them.
I could indeed, yes. It was just west of Parkes, which is in outback New South Wales.
Oh, that's not too far away from big cities and things, yeah.
It's part of the journey, yeah.
Well, there you go. So that just shows you when you get into a dark spot, you can see some amazing things in the night sky if you get away from the light, which of course not everyone's able to do, but
I had my own cabin, so it was okay.
Yeah, you could turn the lights off. Yeah, well, a lot of people do like to travel, as I say, and want to do some astronomy when they go to places, whether it's within their own country or another country. So can you take a telescope with you? And yeah, there are lots of really good small telescopes. There are collapsible telescopes and all different kinds, and binoculars, of course, that you can take with you on holiday or vacation. So we've got a really great article that gives you all the advice you need on the best types of small telescopes and binoculars, what sort of tripod to use, what you can expect to see, all that sort of stuff. So taking a telescope with you when you go travelling is a really good way to explore unfamiliar night skies, particularly if you're going from the northern hemisphere to the south or vice versa, and you can make some really, really good memories that'll last with you forever by getting a good view of the night sky, different night skies.
And of course you've got to bring Sky and Telescope magazine with you as well, because it's got those sky charts in it.
It's got the sky charts and everything you can see in the night sky, yeah, but whether it's comets or meteor showers, these variable stars, they're called, these stars that do change in their brightness, double stars, all sorts of amazing things you can see up the night sky. Galaxies, nebulae, it just goes on and on and on. So yeah, if you can carry a little telescope with you when you go travelling, fantastic. Even little ones you can just put on a desk. The little ones don't even have a huge tripod, just a little stand, put on a desk, aim it out the window of your hotel. And some of them can even be computerized these days. So you don't really need to know where you're looking or what you're looking at. You just tell it what to look at and it will do it for you. So it's really quite good. It's marvelous stuff for people who do like to learn a bit of the night sky in an unfamiliar place.
Yeah, just make sure you're pointed at the sky, not in somebody's window. You can get arrested for that.
Can you?
The response is what? Judge told you that, did he?
That's right. The judge told you that. No, I do remember that one now, yeah.
A judge made it very clear to me.
That's right. The judge made it very clear to me. Now, astrophotography, the process of taking pictures of the night sky and, of course, all the stars, planets and galaxies and so on in it. With digital cameras being so good these days and so affordable, astrophotography has never been more popular, of course. So in the August issue of Australian Sky and Telescope, we have a really great article that shows you what to do once you've taken your photos. Specifically, how to bring out all the hidden detail in your sky shots using really simple, standard, everyone sort of got it image processing software. And the results can be really quite remarkable. You can get pictures easily as good as the ones the professionals were taking not too many years ago. So Stuart, there's some really good reading there, and there's plenty more in the August issue, including everything you need to know about what to see in the night sky, equipment reviews, stuff to build, and lots more.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. And US intelligence experts believe North Korea has now successfully developed a thermonuclear warhead small enough to fit on an intercontinental ballistic missile. If the confidential assessment's correct, it means Pyongyang has now crossed the threshold and become a true nuclear power. The new revelations follow a separate assessment by the United States last month, claiming that North Korean dictator Kim Jong-un now has up to 60 thermonuclear warheads at his disposal. North Korea has described the new round of UN sanctions following its latest missile tests as an attempt to strangle the nation, and warned that the communist dictatorship is looking at launching a strike on the American Pacific territory of Guam. Pyongyang has conducted 2 missile tests in the past month using its Hwasong-14 ICBM. Now, as we mentioned in the last episode of Space Time, based on those tests, North Korea now has the capability of reaching the mainland United States, including Los Angeles, San Francisco, Seattle, and all points west of Chicago. Pyongyang's also conducted 5 nuclear tests since 2006. The latest, on September the 9th last year, involved a thermonuclear weapon in the 20 to 30 kiloton range. That compares to the 18 and 20 kiloton bombs dropped on Hiroshima and Nagasaki in 1945 to bring an end to the Second World War. US President Donald Trump has promised Pyongyang fire and fury like the world has never seen if the isolationist nation continues to threaten the United States. A new study by the University of North Carolina estimates that future climate change, if left unaddressed, is expected to cause roughly 60,000 deaths globally in the year 2030, and some 260,000 deaths in 2100 due to climate change's effect on global air pollution. The new findings, reported in the journal Nature Climate Change, adds to a growing body of evidence that the overall health effects of a changing climate are likely to be overwhelmingly negative. This is the most comprehensive study yet on how climate change will affect health through air pollution, since it makes use of results from several of the world's top climate change modelling groups. As climate change affects air pollutant concentrations, it can have a significant impact on health worldwide, adding to the millions of people who already die from air pollution each year. You see, hotter temperatures speed up chemical reactions that create air pollutants like ozone and fine particulate matter, both of which have major impacts on public health. Locations that get drier also have worse air pollution because of less removal by rain and increases in wildfires and wind-blown dust. We're already seeing that happening now. And as trees respond to higher temperatures, they'll begin emitting more organic particles such as pollen. In addition to exacerbating air pollution-related deaths, climate change is also expected to affect health through changes in heat stress, access to clean water and food, severe storms, and an increased spread of infectious diseases. New research warns that loneliness and social isolation may represent a greater public health hazard than obesity. The study, reported to the annual convention of the American Psychological Association, found a strong correlation between loneliness and premature death. Researchers examined 70 studies representing more than 3.4 million people from Australia, North America, Europe and Asia finding social isolation, loneliness, or living alone had a significant effect on the risk of premature death, one that was equal to or exceeded the effect of other well-accepted risk factors such as obesity. Being connected to others socially is widely considered a fundamental human need crucial to both well-being and survival. Extreme examples show infants in custodial care who lack human contact fail to thrive and often die. The study found approximately 42.6 million adults over the age of 45 in the United States are estimated to be suffering from chronic loneliness. In addition, the most recent US Census data shows more than a quarter of the population lives alone, more than half the population is unmarried, and since the previous census, marriage rates and the number of children per household have both declined. In fact, many nations around the world now suggest that humanity is facing a loneliness epidemic. A new study claims people who survive a stroke or mini-stroke without early complications have an increased risk of death or another stroke or heart attack for at least 5 years following their initial stroke. The findings, reported in the Canadian Medical Association Journal, mean there's a real need to maintain risk reduction strategies, medical support and healthy lifestyle choices over the long term, even years after a mild initial event. The study included 26,366 patients who had been discharged after a stroke without complications in the first 90 days at regional stroke centres across Ontario between 2003 and 2013. The researchers found that in the patient group who had not experienced complications in the post-stroke period, the risk of complications was significantly higher over the long term compared with 263,660 matched controls. In fact, at 1 year, some 9.5% of people experienced an adverse event such as death, stroke, heart attack, or admission to long-term care. And that figure increased to a stunning 23.6% at 3 years and 35.7% after 5 years. And finally for now, a new study has found that humans can identify emotions in the voices of all air-breathing vertebrates. The findings, reported in the Proceedings of the Royal Society B, could represent evidence of a universal code for vocal expression and perception of emotions in the animal kingdom. Previous studies had already demonstrated that humans are capable of identifying emotions in the voices of different mammals. The new study's results have expanded this to include amphibians, reptiles and birds. Participants in the study included 75 individuals whose native language was English, German or Mandarin. They listened to audio recordings of 9 different species of land-living vertebrates and were able to distinguish between high and low levels of arousals in the acoustic signals of all animal classes. To do so, they mainly relied on frequency-related parameters in the signal. The findings suggest that fundamental mechanisms for the acoustic expression of emotions exist right across all classes of vertebrates. The evolutionary roots of the signalling system may be shared by all vocalizing vertebrates. This finding goes in the direction of what Charles Darwin suggested more than a century ago, namely that acoustic expressions of emotion can be traced back to our earliest land-dwelling ancestors. What it means is that when your dog or cat sounds like they're hungry, they probably are. I'm Stuart Gary. This is SpaceTime. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.